Alright, in 6.3 rational expressions, before we start this assignment or these notes, I want to talk about what it means to be rational. To be rational, we've talked about these numbers, 1, 2, 3, 4, and so on. These numbers are what are known as the natural numbers. We add 0, we get whole numbers, we add negatives, we get what are known as integers, and then the next set of numbers are known as rational. Rational numbers are any value that can be written as a fraction. So, for example, if I give you 0.3 repeating, this can be written as 1/3. If I give you just the number 4, 4 can be written as 4/1, it's now a fraction, or we could even do 8/2 and it's a fraction. So any number that can be written as a fraction is known as a rational number. So here we're going to evaluate rational expressions in both radical form and in rational exponent form. So that means you're going to have some exponents now that are fractions. A square root, this says for any real numbers a and b, if b squared equals a, then b is the square root of a. I'm going to show you where this comes from. If I take this b squared equals a, and I want to solve for b, I'm going to get b all by itself. Then I have to do the opposite of what is happening to the b. It's being squared, so the opposite of squaring is to take the square root. And if this little 2 isn't here, we know it's a square root. So the square root of a b squared is b, and b equals the square root of a, and that is what that says there. The nth root, it works the same way for any real numbers a and b and any positive integer n. If b to the nth equals a, then b is the nth root of a. So it's a mouthful. This says if you have b to the n equals a and we want to get b all by itself, we have to do the opposite of taking it to the nth power. The opposite of taking it to the nth power is to take the nth root. And once you take the nth root, you get b equals the nth root of a. And that's what this expression says. So I could give you an example, like if I have 2 to the third equals 8, then how do I find out what 2 is? We would take the cubed root of both sides. That would get rid of your exponents, and so we know 2 is the cubed root of 8. I think I'm going to show you an example right here. Okay, so here I have 2 to the fourth is 16. Another way that we can write that is we can take the fourth root of both sides, and that leaves us with the 2 here is the fourth root of 16. Now, I explained this, it's probably not a mathematical way to explain it, but 16 breaks down to 4 times 4. 4 breaks down to 2 times 2 times 2 times 2. You've probably seen this as the prime factorization. And what this 4 is saying is that you have to have 4 of the same number to bring it outside of that radical. So here I have 4 2's, so the fourth root of 16 will be 2. We're going to explore this some more. I just have this expression so you can learn some vocabulary or some math language. That a is known as the radicand. This little symbol, you guys have known it as a square root, it's called a radical. We call it a square root when this value is a 2. When it's not a 2, then we call it a radical. That n is known as the index. A rational exponent, this says let a to the 1/nth be an nth root of a, and let m and n be a positive integer, so that we get this expression. This says a to the m over n is equal to the nth root of a to the m. And these are, we can write these both ways, and I will expect you to write them both ways. So what I do want you to notice is that this n, if it's in the denominator of that fraction, it becomes the index. The m here becomes the power on the radicand. This other one shows you that if we have a negative exponent, and this is what we learned in our previous assignment, if you have a negative exponent, it takes the entire expression to the denominator of the fraction and it removes that negative. As long as a cannot be 0, because you can't divide by 0. So here we're just going to practice writing the expression in radical form. So here it has a rational exponent, so radical form, remember that this 4 here means that it's going to be the index of our radical. And that would be 3 to the first. Because it's a 1, we don't need that power. On B, this would become the 6th root of 5 to the first, and again you don't need that first. And what this means is that we need a number that multiplies by itself 6 times and gives you 5. Now, it has to be the same number, so it's obviously not 1. 1 times 1 times 1 times 1 times 1 does not give you 5, it only gives you 1. So you can see there that this number here is not going to be an integer, it's going to be an irrational number. But that's not asking you to find it, it's just asking you to write the expression in radical form. On example 2, we're going to write the expression in rational exponent form. So we're going to go the other direction, and we're going to write this now with a fraction in our exponent. So 7 to the, remember this is our power on top, so 1 over 4, the index is the denominator. On B, we would write this as 27, and there's a 1 there, to the 1/3. These two expressions are equivalent, as are on A they're equivalent, as on example 1 those two are equivalent as well. So on example 3 this says simplify each expression. If you're not comfortable seeing it this way, then we can look at it as the cubed root of 64, and I don't care how you rewrite that or how you use it to solve, as long as you understand the principle that's going on. Now 64 I know breaks down to 4 times 16, and then the 16 breaks down to 4 times 4. So you can see right here that we have 3 sets of 4s, and that's what the index is telling us, that we need 3 of the same number that multiply to give you 64. So this answer is 4, as is the answer above. And I don't care how you look at it or how you write it to solve it. Either way you write it, that's what that's asking you to do. So on B, this is asking you what 4 numbers multiply to give you 625. So I know that 5 goes into it because it ends in a 5. So it's 5 times 125. Again, 125 ends in 5. So it divides by 5, and it's 5 times 25. And 25 is 5 times 5. So you can see we have 4 values. So the answer to this expression would be, not 4, sorry, would be 5. We have 4 5s. It needs 4 of them to bring 1 out. On C, I'm going to show you what this looks like in radical form. Or sorry, radical form. This says the cubed root of 27, and I'm going to actually take this power right here and move it to here, which you can do. The cubed root of 27 is 3, and 3 squared is 9. There are 2 ways to solve that, but I think it's easier for you to pull the exponent out and then work with it later. Okay. On example 4, it says use your calculator, so you can either type in 125 raised to the 1/3. That should give you 5, and I have this part typed wrong. If you're, there's actually a cubed under math, but if it's greater than a 3 right here, your index is greater than 3, then you would actually type in that number, say, in this case I'll say 3, and then I would type the math button and choose this one. I think it's the 5th button down. Choose 5, and then it would make that the index on your main screen, and then you would type in 125, and that would give you 5. On example 5, we're going to solve each equation. We've solved these before. but it's been a while, so what we're going to talk about is we want to create bases that are the same. Now those bases are not the same, and you can do this, but we're not going to do it. You're not going to make the bigger base become the smaller base. We're going to do, instead, we're going to make the bigger base become the smaller base. I may have said that wrong. So we're going to work with this 243. I know that 3 to the first is 3. 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is 243. Hey, there it is. So I'm going to take that 243 and replace it with 3 to the fifth because they're equal expressions. We call that substitution. So we have 3 to the x equals, I'm going to replace that 243 with 3 to the fifth. The bases now will cancel because they are the same, and then we say the exponents are equal, so x is 5. On B, we're looking to do the same thing. We're trying to make the bigger base become a 2. So we're going to say 2 to what power gives us 32? Well, we did 2 to the third earlier. That's 8. 2 to the fourth is 16. 2 to the fifth there's 32. So we're going to replace that 32 with 2 to the fifth. And it's 2 to the 4x equals 2. Now, because these bases are the same, I'm going to put an index of 1 so that I can see that. Not an index, the exponent of 1. Here the bases are the same. They will cancel. When we have a power to a power, and that's a rule we've learned. I think we learned that in section 6.1. When you have a power to a power, you multiply those. 5 times 4x gives us 20x equals 1. To solve for x, we divide by 20, and x equals 1/20. Alright, that should help you with your assignment. 6.3 Rational Expressions worksheet. Good luck.